Hello guys and welcome. I hope that you're having a good morning or a great day or a good evening. My name is I play 4K, AK I play AK, AK I play 16K or UHD King. During this video today, I'm going to show you Batman Arkham City running on 16K resolution rendered in real time, downscale to 8K native, so I'm running 8K native TV plus DSR on a single Titan RTX video card Turing GPU architecture and very old school CPU. This video will be about an hour. Grab yourself your favorite drink. Today we're going to talk a lot about the Turing GPU architecture Titan RTX and in whole Turing GPU architecture and a whole GPU by NVIDIA, as well as I'm going to share a lot of great tips and experience with you when it comes to 8K resolution and 16K resolution. I was the first YouTuber that introduced to you in 2016 the first 16K resolution rendered in real time. It was Half-Life 2. And right now we're going to continue this tradition, and hopefully with Turing GPU architecture I'm going to show you around 90% of the games running 16K resolution rendered in real time. As again, this is not about the gameplay, this is the benchmark, so we're going to know how the technology grows over the time, and we can compare with the different video cards, different CPU, different GPU, etc. So let me go ahead and first of all I'm going to show you that I'm not one of those copycats benchmarks that, by the way, copy me, and there is like a lot of them. Before it was the people on YouTube that was spamming, and now they turn into the benchmarks, and they spamming through their videos. They probably using GTX 1080 look like on their load, but they pretending like Titan RTX, RTX 2080 Ti, RTX 3080, RTX 3090. I'm not sure what is the point of those people, but you will see it's easy to spot it, but beginners doesn't understand it. But people who's watching my channel understand. They know exactly what will be the GPU load on Turing GPU architecture, Pascal GPU architecture that I had before, 4 Titan XPs in SLI, 2 GTX 1080 Ti in SLI, 4 Titan X Maxwell GPU architecture in SLI, 4 Radeon Pro Duo, 2 Radeon Pro Duo, each had the Fury X GPU, 2 of them on each Radeon Pro Duo, so 4 Radeon Fury X and Crossfire. But anyways, this video is not about it. I believe this video is about to show you the performance. So let's say in 2021 or in 2022, if you looking to build a system, you know what your system will be capable of, and you watching 7 years in advance. As again, grab yourself a favorite drink. This video will be an hour. This is an introduction. I will try to post the codes in the video so you can skip to the points that you want, but if you're one of my fans, if you're subscribers, I advise you to watch completely. It's going to be multi-angle value to you, multi-angle informational value. So desktop settings, I'm running 100% because we're going to run Batman Arkham City in windowed mode, and I decided to run my desktop at 100% for those naysayers, just in case if they're going to come up with some scam. Okay, so 15,300 pixels by 8,640 pixels, which is 133 megapixel, or to be exact 132.5. So megapixels, it's a future. It's the end of the PC gaming resolution, 16K resolution. Windows 10 Pro doesn't support resolution above 16K, at least in 2020. As you can see, I'm using the zoom right now up to 400% right here, and so at least you can see it, but I'm not advising you to run 100%. You can run at 500%, which is recommended by the Windows, and it looks beautiful on the 8K resolution TV. Okay. This shot, this is the system actually, this is my gaming system. Today I'm going to show you my workstation, my rendering firm, network rendering firm, pretty much for video encoding, my secondary system, and for the 3D modeling, 3D rendering. But this is the gaming system on the background, and over here will be this system right here. This is rendering firm. Okay, it's using the old school motherboard that I used to use in 2014, 2015, and I replaced the 4930K CPU that was overclockable to 4.2 stable, 4.2 gigahertz stable per 6 core, 12 threads. I replaced it with what? I replaced it with the Intel Xeon E5-2697 V2 that featuring 12 physical cores and 24 virtual cores if hyper-threading technology is enabled. So this is the enterprise horse, beautiful. I believe the best CPU when it comes to Ivy Bridge to scaling, especially when we're talking up to 4 cores, because Intel fitted 12 cores, so to be able to make sure they're going to function right and the utilization will be correct, they did a great job. And when we're talking just 4 cores, they utilize beautifully, the better than any Ivy Bridge quad core 4-core CPU. Okay, so why I'm not running 12 physical cores and 24 threads? Because I believe the hyper-threading technology that comes with virtual threads is slow you down in PC games when you're not utilizing your cores up to 95-100%. And in PC games we are not, especially where we're talking 8K resolution and above, utilization of the cores, 4 cores and 8K resolution and above is more than enough. Okay, in 95% of the games that I tested, when we're talking 16K resolution, we can even go with 3 or 2 cores for the old school games. 2 cores for this game is not enough. Sometimes I see 95 and 100% CPU utilization, so I decided to enable 3 cores. Unfortunately, Xeon E5-2697 V2 CPU has the multiplier lock, and don't listen to naysayers. No motherboard will help you with that. So it's only overclockable through the base clock, bus speed right here under the CPU Z. Let me zoom in further so you're gonna see. 600% zoom, wow, on 16K resolution, can you believe it? So it's way above 32K resolution right now. So, and as you can see, 105.99, so 106 megahertz on my base clock BCLK frequency. It comes with 100 megahertz, so just 6 megahertz overclock on the base clock BCLK. I'm receiving additional 200 megahertz no matter what the scenario is. And just because the CPU is locked, to be able to even overclock even further automatically by Intel, I need to reduce the cores. And then starting after 5 cores. 5 cores is using 31 multiplier, otherwise it's using 30 multiplier, and then 4 cores using 32 multiplier, 3 cores using 33 multiplier, and 2 cores using 34 multiplier, which is 3.4 gigahertz at stock, 2 core 2 threads, or you can do 2 core 4 threads. But as again, no hyper threading, no virtual cores. I'm liking only the physical cores to minimize the latency delay in milliseconds as much as possible. And 1 core is 35 multiplier, which is 3.5 gigahertz. Unfortunately, we cannot run 1 core, we cannot run 2 core in this game, but 3 core will do just great. So the scenario is, I will explain to you during the game, but anyways, 30 megabyte level 3rd cache, 20 ways, just because 3 cores, 3 threads, I'm sharing that. It's a shared cache, and it's great. And so instead of 20 ways, I'm sharing in 3 core, 3 threads. Here we go. As you can see, main board, Gigabyte X79 UD3 version 1.1, not version 1.0, version 1.1. It says on the motherboard. And with the latest BIOS from Gigabyte website F20 from March 19, 2014. This is the only BIOS that's going to accept this CPU and going to boot up and load with this CPU. Otherwise, it's not even going to load and not going to boot with any other BIOSes, official BIOSes. Memory, 32 gigabyte DDR3, of course. This is DDR3, my old school 2014, from 2014. Motherboard, quad channel though, 256-bit. This CPU cannot run the DDR3 above 1400 megahertz. It's just not posting at all, even if I'm using 1866 megahertz, and I know it's working with the i7 4930K, but it's also working with the E5 2640 that I tested, V2. It's working, but it's not working with this particular top-end Ivy Bridge EX CPU 2697 V2. So I know that 1400 megahertz is working, but it's not stable over 12 hours. This frequency 1100 is stable over 12 hours. It's stable over, I tested 7 days. There is no blue screen. Okay. Titan RTX, 24 gigabytes of VRAM, GDDR6 by Samsung. This is what allows us to run this game in 16K resolution. Before, it wasn't possible with Titan XPs or Titan X Maxwells. Okay. And I will explain to you how Titan X Maxwells and Titan XPs was running this game, by the way. I was testing it as well. This is how it tested. Somehow CPU Z doesn't see that CPU has 3 cores. It thinks that CPU has 2 cores. This is how I'm scoring exactly. This is how I'm scoring with 2 cores and 2 threads. So 350 my single thread performance, and 3 core 3 thread performance 700, but should be around 900. So CPU-Z saying multi-thread ratio 2.0, which is perfect if I would have 2 core of 2 threads. And this is how it is at 2 core 2 threads on this particular CPU. It's just 2x boost. This is just amazing. This is unheard of for this Ivy Bridge EX CPU, when 2x boost over 2 core 2 threads. Even 4 core 4 threads almost has 4x boost. And this is exactly for this particular CPU, because Intel did the magic, because so many cores, they did their best to make sure they're all going to be utilized properly. But when you cutting them down through the BIOS, they're utilizing fantastically well. Okay, so this is what's up. But in the game, it's going to recognize 3 cores, and in any other applications, it's recognizing 3 cores. Unfortunately, somehow CPU-Z goes to 4, 2, 4, 6, 8, 10, 12. It doesn't see that kind of, I'm not sure. I think this is the developer's issue. They just, the way they wrote the algorithm, they didn't know that CPU can come with 3 or 5 or 7 cores, which makes sense. But in our case, I want to make sure that I have enough CPU cores to process the game, so we're not going to be slowed down by lacking of the cores on our CPU. 3 core 3 threads will be more than enough. We're not going to see 90% of CPU utilization on overall CPU utilization. Okay, and plus we're going to run very cool, by the way. When I'm running 12 core 24 threads, I'm running like 45 Celsius, 47 Celsius. We went down by 10 Celsius. I'm running today H100i Pro XT, I believe 3rd version, just like on the picture, on the background, Corsair water cooler, but without the liquid metal. Temperature can go by 10 Celsius or by 5 Celsius, even lower than that, with liquid metal thermal compound paste by Liquid Grizzly. Very soon I'm gonna do that. But this is workstation, and you know, I decided it's good enough for me. Everything which is below 90 is more than good enough for me. Below 90 Celsius temperature on the CPU. So keep your mind, when I'm going to overclock my Titan RTX, the value of the pixel fill rate, this 169.9 gigapixels, texture fill rate, which is 509.8 gigatasks, and bandwidth, which is 672 gigabytes per second, will be increased dramatically. And this is how we're going to get the boost in terms of the FPS and in terms of any computing using our Titan RTX Turing GPU architecture video card by NVIDIA. Right now it's running completely stock. I'm going to show you all kind of different presets. I'm going to show you stock preset, just one bench. Then I'm going to show you 3 different benches, which is ambient occlusion, on, off, and physics is on, off. And yeah, so about 4 or 5 tests total. Alright, let's go ahead and get going, guys. And by the way, this is the first video of the Batman Arkham City in 2020. Let me demonstrate it to you, in October 11. And I'm the first YouTuber who does it. I don't like to be a copycat. I hate those copycats. I put for you those 3 cores utilization. So I'm going to open the Steam, and let me go ahead and do that. Here we go. And under the Steam, I'm going to click play. And then I'm going to select, go to configure PC options, because the game doesn't have the video option, so you cannot set the video option in PC game. for this particular game. Configure option, click play. It's gonna bring me the menu. In the menu, I'm going to go ahead and put the settings. So I'm going to do the restart of the game every time we're going to change the settings, which is excellent, by the way, because it's going to be precise. Okay, where is the window? The window is supposed to appear, and I don't see it. Oh, okay, it's right there. Here we go. It was behind this theme. Oops. Oop. It's in the middle somewhere. Guys, I'm using the zoom tool just to show you what's going on. I decided to use 100% my resolution instead of 500 as Microsoft recommended. Just to prove to those naysayers just one thing, okay? Alright guys, 16, but I'm not going to waste a lot of time for naysayers. 16K resolution, okay? So actually I'm going to show you 5 or 6 tests because there is DirectX 11. So it's going to run DirectX 9 and I'm going to show you DirectX 11 as well. So detailed, motion blur will be off because the FPS is not going to be at 60 FPS. So what's the point of motion blur? At least you need to have 60 FPS for motion blur. Ambient occlusion will be yes. Let's start with no. Let's start with ambient occlusion no. Physics will be maximum at high. And then I'm going to disable it as well. DirectX 9, 16K resolution, 15,360 pixels by 8,640 pixels, 133 megapixels to round it. And yeah, let's go ahead and start it, guys. Okay, I'm gonna click OK. I'm not gonna cut this video, and I'm gonna click play. This video will go raw as it is. I already recorded the Batman Arkham Asylum in what's going on here? There's something error right there. Let me see. Approved vice game fatal error. I'm not sure what it is. Let's go ahead and do it again. Click play. Let me go to options just to make sure. Configure. I just played it. It was beautiful. But anyways, I already recorded Batman Arkham Asylum in 16K resolution. Go ahead and check it out. I recorded with 12 core, 24 threads, just for those naysayers, just as some example that they believe that some cores you're going to see that how many cores actually will be utilized. All right, did it ambient occlusion? No. Motion blur? No. Physics? Okay, good. Play. I don't like that error. Here we go, it's loading now. Why it was an error? Okay, this is the maximum possible font at the left top for the display information system that I'm showing to you about my system in real time, updated every second. Above that is not showing under the NVIDIA. This is exactly what this is how small it is. Thanks God this game has a benchmark, so this is how we're gonna do. Unfortunately, this game doesn't have the options where I can manipulate and adjust the options of my screen. It has the audio controls. Alright, the benchmark. Let's go ahead and run the benchmark. Look at this, even this little image is not ready for 16K. Look, it's just beautiful. It's look like the Batman Arkham Knight, which is the last Batman in 2020. It's amazing the way it looks on 16K resolution, guys. Hopefully you can see it, even if I'm running 8K resolution, but there is such a big difference, 8K native rendering or 16K resolution rendering and downscale to 8K native. You just can see it. It's just a big difference, guys. It's just beautiful. You can see that physics, those newspapers flying, this is created by physics. Guys, I ran with 12 core 24 threads, this benchmark, and the difference is 2x versus 3 core 3 threads, but I'm running right now 300 megahertz, at least 300 megahertz. Because I'm running 3 core 3 threads, as you can see right there, it's locked at 3500 megahertz, 3.5 gigahertz versus the 3.2 gigahertz, which is 12 core 24 threads with additional overclock, because without the overclock it's running 2900 megahertz at stock, this Intel CPU. It's beautiful, guys. It's just beautiful. Look at this. Plus, right now I'm recording this video with NVIDIA Shadow Play, and it takes exactly 3 FPS while it's recording. After my testing, I scored 21 FPS on average without the recording. I just bench it. And with the recording, I scored 18. So plus 3 FPS, you're going to have the results to the FPS counter to the left top. You will have the FPS every second without the recording. Shadow Play for this particular game consumed 3 FPS. Beautiful results. Of course, it's not playable, but it's benchable. It's not comfortable to play, but it's beautiful. Let me show you how beautiful it is for those naysayers. Let me bring the zoom tool. This is 600. Look how texture. Man, you're just wasting your textures. You're wasting your textures. This is the way to wasting textures. No, buddy. Your father wastes your Siemens. His Siemens. This was the waste. Look at this. You can see all the details. Because as you can see, all those objects, 3D meshes, they're so small, but just because there is gigantic amount of pixels can be rendered, so they all right here, every single detail. When you play in 1080p or 4K, you're not gonna see that, those details over here. You're just plain simple not going to see those type of details. And this is without any artificial intelligence yet. I didn't use any of my ideas through the artificial intelligence how to improve the visuals in the games. I didn't do that yet, but I'm working on it, guys, as a software developer. So I have a lot of experience as a software developer, graphic designer, 3D artist, hardware enthusiast, PC overclocker. I'm actually PC overclocker and hardware enthusiast, PC hardware enthusiast since 1997, since my first 386 IBM computer that I made myself. It didn't run the Doom, it didn't run the heavy games, but it was okay for Wolfenstein 3D. Why it didn't run the Doom? Because it required the DX version of the coprocessor that 486DX only had before the Pentium and stuff was introduced by Intel. So it's beautiful, guys, okay? So average 18 FPS. This was the Titan RTX was running stock. You saw the GPU the VRAM, video RAM on the Titan RTX utilization is right now 12,195 megabytes. So it's impossible to run this with RTX 2080 Ti because you're going to overload your VRAM at 16K resolution or any other video cards that doesn't feature 12 gigabyte of VRAM. And Titan RTX, Titan XPs and Titan X Maxwells, they featured 12 gigabyte of VRAM and it was 12,460. So they would be fine here with 300 megabytes of extra left, but DirectX API doesn't understand that, and sometimes when you coming close to your VRAM overload, it just stressing and loads that data directly into the system RAM, and you can see that system RAM will have very heavy usage. And I believe this will be the case with RTX 2080 Ti. It probably still can be runnable, or maybe not, we don't know, but it's going to offload a lot of data to the system RAM, and it's going to be runnable like 1-3 FPS, so it's not going to be runnable actually. This is the sign of the VRAM overload, when VRAM stored data stored in the system RAM, and system RAM is so slow, like, oh my god. Alright guys, 18 FPS stock, completely stock, right? Let's go ahead and fix that. Let me bring the show you something. So I brought the Titan RTX MSI Afterburner, where I'm going to overclock it through the software, And you're gonna see the pixel fill rate as again those value, textual fill rate, and bandwidth will increase dramatically. So click on that. Unfortunately, I'm apologizing about the noise because you're gonna hear the fan rotation, because fan rotation will be 100%. And in a small room, it's kind of noisy, okay? And even in the bigger room that I'm using right now. So I click on that, boom. Here we go. You probably hear some noise in the background, especially if you're using the headphones, because today I'm running the professional, I'm using the professional mics. So immediately 179.5 gigapixels, my pixel fill rate, textual fill rate will be 528 gigapaxels, and the bandwidth will be 768 gigabytes per second. Value increased by a lot actually. Great overclock for free. This is the free overclock. So excellent. Now we're going to go ahead and bench it again. We're going to see what's the difference in overclock. And in my theory, let me real quick go ahead and explain it to you. In my theory, when your FPS 30-40 FPS average without the overclock, your increase will be 2-3 FPS through the software overclock. When your FPS 50-60 FPS without the overclock, your increase will be 4-7 FPS. When your FPS without the overclock 90-110 FPS, your increase will be 7-10 FPS. Hopefully this makes sense. So as you can see, we're increasing some, basically it's about 10% on average. And overclock dozens of video cards, different architectures, guys, and this is almost the same. This algorithm almost the same for the video cards. You immediately can see the jump on average translation of FPS by 1 FPS, but then it's going to also increase by 20 by 20. So 3-core 3 threads at 3.5 gigahertz running 2 FPS faster than 12-core 24 threads at 3.2 gigahertz. Only 300 megahertz difference. And on this CPU to be able to overclock it farther, because it's not about the cores, it's about the frequency, as I already explained to you, per each core. When you can see your overall CPU utilization, right now you can see 86, 63, 68, 74. When that value is below 90, and you never see 95% or 100% ever, not a second, not a half second, you're Gucci. That means that you're good to go on your cores, especially when you're load like below 90 all the time, and you didn't see 90. That means that you're Gucci all the time. And what you can do, you can lower your cores to keep the temperature down and overclock your CPU if you have unlocked multiplier like an old desktop CPUs and laptop CPUs. For the enthusiasts, or for the Xeons, you can pretty much overclock through the BCLK, but that not gonna give you too much. Maximum 200-400 megahertz. It depends on the motherboard. Increased by 2 FPS, just the overclock, as you can see, beautiful. As again, that 2 FPS, if I would overclock it and run the game without the recording with the shadow play, as I'm doing that, recording with NVIDIA shadow play software on the same computer, you can compensate that just through the software overclocking on your video card. Keep that in mind. Alright, so this is with the ambient occlusion off. Let's go ahead and use only the overclock now. Yes, which is on, and then I'm going to turn down the physics, and then I'm going to use the DirectX 11 as well, with the physics without the ambient occlusion and with the ambient occlusion. So we're going to go ahead and play it again. I'm going to click play. Actually, let me, you know what? Let me go ahead and, here we go, guys. Here's what we're going to do. I'm going to run DirectX 11 right now. Hopefully the game is not going to crash on us. I never run this game at 16K resolution DirectX 11, and we're going to find out now. Where'd that window go? Here we go. Oh, let me show you the CPU utilization during our benchmark. This is very long table, as you can see. So you can see we never utilize single core at 100%. the more cores, the higher latency delay, because the CPU controller cores that managing the cores. First of all, going to check how many cores CPU has. Okay, that many. How many cores are loaded? Okay, that many. How many is loaded the lowest? Okay, that many. Okay, I'm gonna send the instruction to that core. All this takes some time. Okay, and the lower amount of cores you have, the faster CPU controller will check it, and the lowest latency delay will be the higher FPS. This is the scenario for the games. Okay. So what I'm gonna do, I'm going to go ahead and enable DirectX 11 feature. Unfortunately, with DirectX 11 feature, it's only using the MVSS and HBAO and distillation normal or high. Let's go ahead and do with normal. I cannot turn it down. Turn down the whole, as you can see, deal. So this is how we're going to do it, guys. This is how we're gonna do it with the physics on. Ambient occlusion, no, which is disabled. And then I'm going to run the same deal with the DirectX 9 just to see the comparison. DirectX 9 API, rendering API, and DirectX 11 rendering API, just to see the difference. Look how small that Steam window right there at the right bottom corner. Wow, such a small deal. All right, you can see DirectX 11 API. Let's see what is. I'm just going to use the keyboard instead of mouse. Mouse cursor is such a small, as you saw. Okay, let's have a look. Is DirectX 11 API going to boost us up, or is it going to slow us down? Slow us down, 16, 17, or maybe it's going to be the same. Pretty much they're using almost the same algorithms, only the DirectX 11 API has additional algorithms that you can use, like a tessellation and some other methods and features. And DirectX 9 doesn't feature that. DirectX 11 API for rendering your games was introduced, I believe, 5 or 7 years after DirectX 9, so 7 years, I believe, after. As again, I'm talking about the DirectX 9 and DirectX 11. And DirectX 9, it was different revision, A, B, and C. C was the top dog of DirectX 9 API. Yeah, let's slow it down, guys. 15 FPS. Slow it down. Maximum and slow, below 20. So you better run this game with physics, DirectX 9 without the tessellation. But with the tessellation, it's a little bit even on another level in terms of the 3D meshes for the characters. This is the tessellation. You can see those details. We didn't see those details before. It's looking like a higher topology for the 3D mesh, more polygons. Tessellation pretty much just creating the polygons. Look what's going on here. I'm not sure what's going on. Let's let a little bit slow down. GPU utilization 99%. This is exactly how we want to keep our GPU utilization. Means that we're utilizing all the shader cores. Look, my CPU utilization never went 90%. 16 average, so we're down by 4. But as again, it comes with the tessellation. We improve the topology for our 3D meshes. Every mesh now, not only the textures, but like 16K resolution rendering for the textures was kind of rendering all kind of details of the pixels of the texture, but also we improved the topology of the increased the polygons by improving topology of the 3D mesh. Every single mesh is on the screen. All right, 16. So by 4 FPS. Wow. DirectX 9 API is faster, and DirectX 9C in this case. All right. Let's get back to DirectX 9, and I'm going to go ahead and enable the ambient occlusion, and FPS going to go down a little bit farther. but I'm just curious what it's going to be. Look at my CPU utilization, excellent actually. This is excellent CPU utilization, was in that game. Guys, if your cores is not utilized at 100%, not even 90%, you don't need an additional cores. This is the rules. And when you see some cores utilized at 90%, as again, it's still not a sign for you to increase some core count on your CPU to upgrade to better CPU with like at least 2 more cores. The sign will be only when you're playing games. As again, this is for the gaming PCs. When you're playing the games, you can see your overall CPU utilization jumping to 90% and sometimes above 90%. This is the clear sign, because Windows is kind of also have a controller, the software controller that controlling and see it doesn't want your CPU kind of be overloaded. So it's kind of decreasing the instruction and it's going to decrease the FPS. Hopefully, guys, this makes sense. I'm telling you this as a software developer. Those copycats on the YouTube reviewers with multi-million channels, they're not going to tell you that, because they're all about to sell you some crap over the crap over the crap every year. This is what the game paid for. Alright, so of course, imagine, oh, look at this. Now we can, oh, now it's controllable. Can I disable this feature and just enable the I can disable the tessellation and only run with MVSS and HBAO, but there is not such a difference. I would rather disable the HBAO and instead of increasing the tessellation. So there is no reason for us to do that. Let's go ahead, guys, and enable the ambient occlusion. Let's go ahead and have a look how it's going to look with the ambient occlusion. DirectX 9. Okay. Look at that Steam window, right bottom corner. So small, so tiny. This is how it looks like in 16K resolution, guys. Barely can see there is a window there. NVIDIA. Cannot wait to run this. This is my workstation, guys. This is not the gaming PC. Cannot wait to run this on my gaming PC, which is i9-9900K, overclocked to 5.8 gigahertz per core, and maybe very soon i9 10900K, overclocking the father. Okay. So DirectX 9. Because again, this video will be unedited, guys. And I'm coming in real time. English is not my first language, but I have a lot of experience and I'm sharing a lot of valuable multi-angle information. So don't forget to smash that like button for the support. I need to see that support to record more 8K and 16K resolution videos. And don't forget to subscribe. This YouTube channel, UHDking, or iplay4k.com, or iplay16k.com, or iplay8k.com, is great YouTube channel. Believe me, subscribe and you will learn a lot. It's all about the intelligence sharing and knowledge sharing. See those newspapers flying? When I'm going to turn on the physics, we're not going to see the newspapers. So physics pretty much brings some additional details to the gameplay, but it's not crucial. You can have it or you can don't have it. It's just for the visual. So pretty much with the ambient occlusion on DirectX 9, the same FPS, just like ambient occlusion off, but DirectX 11 with the tessellation. Remember that mesh right here? That mesh was kind of more, had the better, those, how to say it, not the blued out like a texture details, but it has the polygons details, not only the pixel details on the mesh when tessellation was on under the DirectX 11. Remember that. Just go ahead and rewatch this video, you're gonna see it. Almost every 3D model will have a better polygon details to it, not only the texture details to it. So it's not going to be so blurred out. It's going to be like filled out with more details, like more like 3D details, not just 2D texture. So pretty much the FPS same as, like I told you, DirectX 11 with the tessellation on, but this is tessellation off, DirectX 9, but ambient occlusion is on. Great result, by the way, for a single video card. Keep in mind that you can run two video cards, guys, two Titan RTXs, and when we're talking Titan RTX, you better buy them in two. Otherwise, get yourself RTX 2080 Ti. Don't waste your money, okay? This is what I Play 4K told you. Because Titan RTX is not great for 4K resolution. You're not going to utilize 99%. Maximum, if you're lucky, you're going to utilize 90% of your GPU, and it means that you're going to waste 10% of the shader cores, and that means that it's going to be the same as RTX 2080 Ti or even a little bit slower. Titan RTX takes advantage in 6K resolution and above. 8K resolution very heavily advantage, and above 8K resolution, but two of them, this is exactly what's gonna give you that unbelievable experience. This is exactly why you need the SLI, because it's going to be faster as RTX 3090 single video card, two Titan RTX and SLI by about 15%, but still it's going to be faster. And if you're talking about very ultra extreme HD resolution, you better have SLI. My project SLI Ready, guys, is coming. So SLIready.com, where I'm going to teach you how to enable SLI in NVIDIA games that didn't support SLI, so you can utilize two video cards instead of one video card. So we're going to do the same thing with DirectX 11 now. Same thing, DirectX 11, normal tessellation. I don't want to bring the tessellation higher. Maybe in the end, I'm going to do it for the people who's curious. Too high tessellation, but the details will be probably amazing, but the VRAM utilization and everything will increase as well, just to see for the purpose of the VRAM utilization, but of course it's not going to be playable at all, just to bench it. So this is with the ambient occlusion on, guys, physics on. Okay, let's go ahead and do that. Yeah, unique videos, guys, as you can see. You don't want to watch those copycats. All what they do, they're just reading each other, watching each other videos and copying it. What's the point? They're not providing you the value. They're just providing you the information for you to make a purchase. They never test the video cards the way they should be tested. They test them like a couple days. They never share with you a lot of information that you learned over the CPU and GPU by ARM. Alright, enough talking, let's go ahead and get going. Hopefully you're enjoying that. If you're watching it live premiere, go ahead and wait 2 days. This video will be available in 8K resolution. The shadow play is hacked, so it's recording 8K resolution. How it was hacked? It was hacked through the system RAM debugging tool. So pretty much I changed the values of the variables, and I changed it to 680 by 4320, and it's recording at 60 FPS without any issues. It's recording up to 120 FPS actually. I'm not sure why Jensen Huang, NVIDIA CEO and founder, is hiding it from us, but it's available. Maybe in the next updates of the drivers for the RTX 3090 he will unlock it, or maybe for the next video cards, we never know. But this option is available, they're just hiding it from us. And it's working just the way it is. It's not just upscaling, it's just, you just changing the values, and the whole algorithm takes that values and it's executing it correctly. Alright, well, low FPS, but this is DirectX 11. Which is slow, but as you can see, DirectX 11 in this particular game is like 3 FPS slower than DirectX 9. But as again, DirectX 11 API brings some more features. Look at this. tessellation right here. You're gonna see it a lot. By the mesh details, more detailed, more like bumpy. Instead of the texture bumps, it's like a 3D bumpies. See that? This is the tessellation, guys. And this possible only when you increase the polygons count. You saw how the line changed the polygon counts from lower to higher. This is probably when it was a little bit to slow it down. Maybe it was tessellating some 3D objects, but because 16K resolution, maybe it just, remember that first test, DirectX 11 and this benchmark was kind of hiccups. So we never know. Maybe it's level second cache on the GPU of during GPU architecture, but it's 6 megabytes L2 cache on this GPU during GPU architecture. 4 megabytes more than Titan XP's. So Titan XP's, Titan X Maxwell, not possible to run it because the VRAM, or if it's going to run, it's most likely it's going to run 1-2 FPS because it's going to overload the system RAM. But Titan XP, it was the CEO version, guys, signed by Jensen Kuyang. One of my subscribers has that video card, by the way, and it's featuring 32 gigs, I believe. And it's nice to put 2 of them. It was Titan XP's 32 gigs CEO version, and it was Titan V 32 gigs. One of my subscribers has Titan V. He proved it to me, so he has it. Alright guys, 15 FPS average. Benchable. DirectX 11. Not playable, but benchable. But with 2 Titan RTX in SLI, it's going to be at least 1.9 times. Almost 2 times. 1.9 times, 1.95 times, so FPS will increase almost by 2 times. Keep that in mind. And then it's going to be playable and enjoyable. Actually, I'm going to record it. Hopefully it's not going to be hiccups or something like that, or kind of like a slow-mo effect. When I was running this game in 8K resolution on Titan 4 Titan X Maxwells, it was that slow-mo effect, because Titan X Maxwell even didn't feature 2 megabytes of L2 cache on GPU. It was running well, but with that type of, I don't know how to explain it to you, like not a hiccups, but kind of like a slow-mo. You can feel it. It's like lack of the hertz of the monitor. But it's created by that stress on the Titan 4 Titan X Maxwells. Alright guys, so what we're gonna do now? Now we're going to turn down, I'm going to turn down the DirectX 11, and I'm going to turn down the ambient occlusion, and I'm going to turn down the physics. We're going to turn down the physics. Oh, actually, let me do one more test with DirectX 11, but without the ambient occlusion, which is the higher FPS, about 16 FPS was like that. But instead of this time tessellation, I'm going to go high, the maximum possible tessellation. Let's go ahead and have a look how it's going to look at that. And you're going to see a lot of topology in terms of polygon counts in 3D meshes. Let's go ahead and have a look like that. DirectX 11, and with the tessellation at high, so it means that every single 3D mesh, 3D model, whatever you want to call it, will feature more polygons as maximum as possible, and you will see it. It's not going to look just like a texture 2D effect, but it's going to be that 3D effect, like bumpy and stuff like that. I'm not sure what's stressing more to you, the tessellation or the shader programming, when textures will have that bumpy effect, just the textures through the programming without the actual polygons. Okay. I think Titan RTX is a powerful video card. I think 14 FPS, maybe 12 FPS, not too much. On the old school CPUs, I mean on the old school GPUs, not the CPUs, on the old school GPUs such as even Titan X Maxwell, tessellation was a big deal. It took about 30% of the performance. On the Titan XPs, it was taking about 15-20% of performance. On the Titan RTX, which is Turing GPU architecture, it takes, what I saw in the games, I don't know about this game, but it takes about 10% of the GPU, which is pretty much your overclock will compensate. Your capital overclock will compensate the tessellation performance. In about 5 games that I tested, I didn't test this game yet. Guys, you don't want to miss the ARMA in 8K resolution and 16K resolution over the UHDking.com. ARMA 3, it's just wow. Even if 8K resolution is wow. Actually, wait, no, ARMA 3 is not runnable. ARMA 3 is not runnable above 8K resolution. Somehow it's blocking it and it goes scaling to 50% when you're increasing the ARMA 3 resolution above 8K resolution. For ARMA 3, yeah. I just recorded the 8K resolution video and it's amazing. It's just photorealism. Look at this polygons. Guys, look at this bumpy. It's much more bumpy right now. Look at these details. Oh, at that high. Almost like at normal. But still, if you're gonna look at this line more, you're gonna see like it did 2 times. So it did without the tessellation, then it did tessellation normal, and then it did tessellation on high. Look at these details. This is the, it could be done as again with the parallax mapping, but this is through the polygons. Wow, average 17 FPS. GPU utilization is perfect. Beautiful. 17 average, guys. 17 FPS average. Plus 3 FPS, which is 20 FPS average without the recording. Great. Around 40 FPS with 2 Titan RTXs. But I'm not going to spoil you an SLI, 2-way SLI. I'm going to show it to you, alright? So subscribe. Don't miss that. That's it, guys. And now I'm going to go ahead and turn on, I'm going to pretty much turn on the physics, and I'm going to turn on the DirectX 11. And without the ambient occlusion. But still, as you can see, it's still pretty much maxed out visuals, even without the ambient occlusion. With the physics and DirectX 9. Even without the physics, it's still maxed out. Physics is kind of going to give you that paper, some effects, some extra visual effects, as I already explained to you. So that's a great thing that I'm rebooting the game every time. So the precise result of the benchmark. This is without the anti-aliasing, guys. We cannot handle the anti-aliasing for sure. I'm probably going to, after that, I'm going to go ahead and try the anti-aliasing just to see what it is. So completely... over 1 hour of video, but completely wrap up the way it should be. I'm showing you all my benchmark techniques, the way I'm doing it, and you see it. There's no lies about it, like those as again YouTube channels that spam people. Value to benefit. They're not bringing the value. They're probably stupid people watching them. Anyways, guys, this is wow. DirectX 9, ambient occlusion off, physics is off. You're gonna see what physics actually brought to us right now during this test. First of all, look at this. The particles, low level. The FPS is great. Oh my goodness. 50 FPS will be with 2 Titan RTXs? Come on. Around 50. The VRAM utilization is also lowered. Probably RTX 2080 Ti can handle it. But for sure Titan XP, which is Pascal GPU architecture, or Titan X Pascal GPU architecture, which is the first version of Titan X Pascal, can handle it for sure, and Titan X Maxwell can handle it for sure. In terms of the GPU, I'm not sure about in terms of the performance. Probably Titan X Maxwell will be probably 3 or 6 FPS average. So you don't see those too much bumpy. There is no too much those bumpy details. Those heavy bumps. Without the with the tessellation, and without the tessellation, they're creating those effects with the texture to the parallax effect. But the parallax effects, as you can see, is not as powerful, as strong as 3D mesh topology through the tessellation improvement. Beautiful FPS actually. So physics for Titan RTX, like I told you, is nothing. Improvement is like 1 FPS. Better play with the physics and have completely the whole average picture. Alright guys, that's pretty much it. That's pretty much it. We're going to go ahead and wrap it up with this. And look, everything is so small. As again, thank you so much for watching. Don't forget to smash that like button. I play 4K, aka I play 8K, aka I play 16K, aka UHDking was with you today. Have a great morning, great day, great evening. Till the next time.